We are doing exercise 7a, and in this video I'll be doing question 3a, which says for y equals f of x equals 1 over x, sketch the graph of each of the following, labeling asymptotes and axis-intercepts. And we've been given y equals f of x minus 1. So I've broken this down into a few steps. We're first going to find what my newly transformed graph will be. We will then find the asymptotes, then the x-intercept, then the y-intercept, and then we'll give it a sketch. And as you can already see, I've drawn in y equals 1 over x, because this is kind of our original graph, and then we're going to be doing something to it, which is going to transform it. So let's begin with step 1. And we know that y equals f of x equals 1 over x. So let me write that in. Y equals f of x equals 1 over x. Now here we're told that y equals f of x minus 1. So let me write that. Y equals f of x minus 1. So as you can see here we had x, but now we have x minus 1, which means that in my x spot, I'm going to put in x minus 1. So I'm going to get 1 over x minus 1. So that means what I'm going to be sketching is y equals 1 over x minus 1. Now hopefully you recognize that this minus 1 here is going to be shifting my rectangular hyperbola 1 unit in the positive x direction. So let me now grab my rectangular hyperbola and I'm going to shift it 1 unit in the positive x direction. So it's going to be about there. So that means I've changed this. Let me get rid of that. Let me put this here. Alright, but let's say you weren't too sure about what this looked like and you wanted some more information before you sketched it. Well, let's find our asymptote and see if that helps us, our asymptote. So we have y equals 1 over x minus 1. And when we're dealing with asymptotes, the question that we're asking ourselves is there anywhere where this is going to be undefined? And there absolutely will, when I have my denominator being equal to 0. So we want to find where that happens. So where am I going to get my denominator being equal to 0? Well, let me do some rearranging. I'll plus 1 to both sides and I'll get x equals 1. And as you can see, that when x equals 1, I'm going to get 1 minus 1, which will be 1 over 0, which is undefined. So x equal 1 will be my asymptote. So I can come here and I can draw in x equals 1, which is here. And as you can see, this proves that it has shifted 1 unit in the positive x direction. This is x equals 1. Perfect. Next, we're going to find our x-intercept, which will happen when y equals 0. So I'll come here and I'll write y equals 1 over x minus 1, and I will let my y be 0. I will then do some rearranging. I'm going to times my denominator by both sides. So 0 times x minus 1 is just 0. So I'm going to be left with 0 equals 1, which obviously isn't true, which tells me I'm going to have no x-intercepts. And that makes sense when we look over here at our graph, because we know there actually is another asymptote right here at y equals 0, which means that my graph is never going to touch my x-intercept. Y equals 0. Now let's find our y-intercept. To find our y-intercept, we will let x equal 0. So let me write out y equals 1 over x minus 1. And I will let x equal 0. Which means I'm going to be left with y equals 1 over negative 1, which will be y equals negative 1, which means that is where my x-intercept is going to occur, so right here. And I'll label that as 0 minus 1. Perfect. So I have my asymptotes, I have my intercepts, and I have my new rule right here. So this is how you answer question 3a from exercise 7a.